x equals x plus 1, and f of x equals quantity x minus 2 multiplied by quantity x minus 3. As a first goal, let's find the domain of this quotient function. So recall, in mathematics, we must never divide by 0. Division by 0 is an undefined operation and thus would not be part of the valid domain. So in this quotient, g of f, f is the denominator. F is the denominator, which is x minus 2 times x minus 3. And we wish for this to never be equal to 0. So let's ask ourselves the question of when does it equal 0? Well, by the zero product property, x minus 2 times x minus 3 would equal 0 if x equals 2 or x equals 3. So therefore, the valid domain of the problem, our domain will be all x's that are not equal to 2 and not equal to 3. In other words, never be 2, never be 3, because these would force zeros into the denominator. Okay, now let's use this and let's evaluate g of f of 1, g over f of 1. So in order to do this, we'd first have to calculate what exactly is g of 1. Well, notice that g of 1 is what we get when we replace x for 1 inside of the g function. So if we replace 1 for x, we end up getting 1 plus 1. Okay, similarly, but not identically, in the denominator we have f. So we need to evaluate what is f of 1. We'll notice that f of 1 would be replacing x for 1 in this expression. So in the first place we'd have 1 minus 2, that's negative 1, and then we'd have 1 minus 3, which is negative 2. So, all told, looks like on the numerator we have 1 plus 1, which is 2. In the denominator we have negative 1 times negative 2, which is 2. And therefore, our final answer is 1. So, pause the video and try this one on your own. Assuming you took a moment out here to try it out, let's first find the domain. Recall, to find the domain, we take the denominator, in this case 2x minus 4, because it's the f function, and we ask when does this equal 0. By adding 4 to both sides, we get 2x equals 4. Dividing by 2 gives me x equals 2, and therefore the domain would simply be all x's that are not equal to 2. The domain is everything but 2. In an interval notation, if you're curious, that would mean from negative infinity up to 2, unioned from 2 off on to infinity, right? Big, big, big domain. Now, let's evaluate g over f of 3. Okay, put an extra couple lines in here because we know where it's going to go. So in the numerator, we need g of 3. When we replace 3 into this expression, we get 3 multiplied by 3 squared minus 2. And that, of course, would come out to become, 9 times 3 is 27 minus 2. That would be 25. In the denominator, we need f of 3. And when we replace 3 into the f function, we get 2 times 3 minus 4, or 6 minus 4, which is also known as 2. So the answer to the problem here would be 25 halves.